So go back to your warm-up page. Let's put another one in here. This is also the same date. Today's the 23rd still. Since we didn't do a warm-up Friday, we're going to do 2 today. And our instructions are write the equation of a line with slope 2, comma, goes through (9, negative 26). This, I'm hoping this looks kind of familiar to you guys. Do you remember back in chapter 3 doing some problems like this? In fact, there were some on our last test too. There was a trick to doing these, to finding the y-intercept. So the first big thing we got to know is, what does the equation of a line look like? Do you guys remember what the equation of a line looks like? Y equals what? Mx plus b. That's awesome. Super happy you're remembering that. And in order to finish this problem, all I need to do is come up with a number for m and a number for b, and we're done. Do you already know either of those numbers? We already know which one. We already know the slope. Is m the slope or is b the slope? M is the slope. So I'm going to rewrite this equation. I'm going to stick a 2 in there. Y equals 2x plus b. We're almost there. All I need is a number for my b value, and we'll be finished. Do you remember what our strategy was to find the number for the b value? Yeah, we're gonna substitute some values in for x and y here. So I'm going to rewrite this, leaving the x and y out. And that's where this point's going to be useful to us. This point gives us an x value and a y value. So let's put those two things into our equation. The negative 26 is y, so it'll go here. And 9 is our x value, so that'll go here where the x used to be. And now we've got a pretty simple equation we can use to solve this thing. So let's use our algebra skills and solve it. So if you guys could, go ahead and solve it. Don't look up at the screen and copy my steps from here. You all know how to solve this equation. You've got some bigger numbers to deal with, but you've got calculators in front of you too. So go ahead and solve and figure out what b is. Again, I would prefer you not to just copy my steps down here. You know how to solve this equation. If you come up with a b value, check mine, see if I made any mistakes. I did some mental math there. I hope I didn't make any mistakes. Is that what you all are getting too? So then I think we have everything we need to write the equation now, right? We just got to put it all together. So our final equation is y equals, our slope was 2. We knew that from the beginning of the problem. X, and I'm going to, instead of writing plus negative 44, I'm just going to write minus 44. Does this look kind of familiar to you? I want you to keep this in the back of your mind because we're going to do something really, really similar today. All right, so any questions on this before we move on? This is key. If you understand what we did here, then you're going to be totally fine with what we're doing today. All right, let's do this. Could you guys turn to our next lesson, which is called 7.1.5. What are the connections between a graph and an equation? So our goal today should be pretty self-explanatory. Our goal is to take a graph and turn it into an equation. Now, we've done this a whole bunch with tables. So that is an option for us. We know how to turn a graph into a table, and then we know how to turn a table into an equation. But I want us to go straight from the graph to the equation if we can. I will tell you there's one problem on this page where we don't really have the tools to do that yet, but the other 5, we can go straight from the graph to the equation. So I'm going to walk you through part A. and I'll get you started on part C, and then you're going to do the rest of them on your own, okay? You guys with me? All right, first of all, when we write an equation, these are all exponential functions. Do you guys remember what our equations look like? It's not y equals mx plus b anymore. What is it? Y equals a and then b to the x power. So same thing as we just did. All I need are two numbers. I got to figure out what a is and what b is, and then we're done. Just got to figure out those two numbers. Now, we've already talked about connections between graphs and the equation. Which of these two numbers, the a or the b value, which one is really, really easy to see on a graph? If you're not sure, remember you got some notes in the back of your packet. I just heard a. Who said a? Where do you see a on a graph, Roman? On the y-axis. Yeah, the y-intercept is a. This is kind of a big key thing. I'm actually going to write this down here. A is the y-intercept. So if I'm looking at a graph and the y-intercept is labeled, and most of these have the y-intercept labeled, then we know what a is. Like I can look right here and say, oh, a is 5. So let's start writing this equation. I know it's going to be y equals, and I know a comes next, but I know a is 5, so we'll go ahead and put that 5 in there. I don't know b, so I'll just leave it as a b. And we'll put our x power on there. And we could have parentheses around this b or not. It really doesn't matter. I'm going to leave them off for this one. So do you see how this is kind of similar to what we just did a minute ago in our second warm-up? In the second warm-up, we had some of the information for our equation, but we were just missing one of the numbers. And that's all that's going on here. We're just missing this b value. How do you suppose we're going to solve for this b value? How did we do it just a minute ago? We put some numbers in for x and y, didn't we? In order to do that, we're going to need some point. Luckily, they gave us some information about a point here. Can you guys look at those numbers and tell me what the coordinates of this point would be? It's over 1 from the y-axis, so this would be a 1. I agree with that. And did you say 7? Well, yeah, what's the x-coordinate and what's the y-coordinate? I agree with your x-coordinate of 1 because it's over 1. It says that right here. And then how high up from the origin is that point? This would be 7 because it's 5 up to here and then plus another 2 gets us 7, right? I agree. Yeah, I see where you're getting the 7 from now. 1, 7, are we feeling okay with that? Cool. Label them, stick an x and a y over it, and let's put those numbers into our equation. So I'm going to rewrite my equation now. 7 equals 5 times b to the 1 power. And now we just got to solve that. Just got to get b by itself. So very similar to what we just did, we wrote as much of the equation as we could, and then we stuck some x and y values into the equation. Now we're just going to solve it. What would be your first step to solve and get this b by itself? What do you want to get rid of first? Get rid of the 5? I agree. Let's divide by 5 on both sides. 7 divided by 5. We could leave it as a fraction, or we could type it in and get a decimal. You want to leave it as a fraction or get a decimal? Fraction's fine. I'm going to get a decimal. I believe that's 1.4. Can someone check that for me? Thank you. 1.4. It is, no matter whether you write it as 7 over 5 or 1.4, it is b to the first power, correct? That's all that's left there. Do we really need this exponent of 1 on here, though? Exponent of 1 doesn't really do anything. So if we erase that, I'd say we're solved. We know what b is. B is 1.4. So let's write our final equation. Y equals 5 times 1.4 to the x power. If you chose to use the fractions instead, a couple of you said you wanted to go with the fraction. Your fraction does need to be in parentheses. So if you wanted to write it this way, the fraction has to be in parentheses. If you're not using a fraction, technically your b value does not need to be in parentheses. You could always put the b value in parentheses if you want. I usually do, that way I'm safe whether I need it or not. All right, there's one done. Let's try another. Let's do C next. Let's do C next. Can you guys tell me a value or a b value just by looking at this? What are you seeing? I see a y-intercept. So a is what this time? A is 7, because that's our y-intercept. A is 7, and b I don't know yet. So let's write down as much of the equation as we can. It's y equals a times b to the x, but I know what a is, so I put a 7 instead of the a. And if we want to find b, one way we could do it is we could put some x and y coordinates in there. So luckily I've got another point. This time they actually gave me the coordinates. I didn't have to do any thinking to get it. I will label them just to make sure I get stuff in the right place. So the equation was y equals 7b to the x power, but I'm going to leave the y out and put 56 there. Leave the x out and put 3 there. And then we just got to solve. And we practiced solving some equations like this on Wednesday. What would your first step be? Yeah, let's get rid of that 7. Let's divide by 7 both sides. I like your thinking. So now this is just b to the 3rd power over here. 56 divided by 7, I believe that's 8. And then how do we get rid of a power again? We use a root. Yeah. This time we're not going to use a square root, though. We're going to have to use a 3rd root because it's a 3rd power. So I'm going to do a 3rd root on both sides. You guys have seen the cube root of 8 pop up on a bunch of your assignments, so some of you might know what that is. If you don't, do you know how to put it in the calculator? If you think you know the answer, write it down, but I want everybody to put that in the calculator, the 3rd root of 8, just to double check and make sure you're correct. I just want to review and make sure we all know how to take 3rd roots and 4th roots and 89th roots. You might be taking a -1 root today. So on these calculators, you need to hit the 3 first and then 2nd, and you're looking for the button that has the x radical above it. So it should look like this. The 3rd root of 8 is 2. How many of you already knew that? Remember that cube root of 8? That's come up a lot of times in our assignments. So b is 2, and we already knew a, so we're done. We just got to write our final equation. Y equals, go ahead and finish it up for me, something times something to the x power. All right, your goal right now is to finish the other 4. And please put a star next to E. I want you to do an E last. If you need any hints on any of these, I'm more than happy to help. All of your equations will be in this format. Even D. D looks a little bit different, but you can write D in this equation format. All right. If you finish early, I would like you to move on to the review problems at the bottom. This is just some review from Chapter 5. You know how to do this. Okay, and if you can't remember how to do this, you've got notes in your packet. Go back to those notes. All right, I did write some notes up here for sequences if that's helpful to you. All right, but your first priority is to finish up the equations up here. If you finish these, get my attention, I'll check them over for you. If you need hints, let me know. We'll come back and chat about these in about 10 minutes. A lot of folks are asking for a hint on E. So I'll provide a hint here for you. My solution to E involves making a table, because we don't have a y-intercept, so we can't really do this problem the same way we did the other problems, because I can't see what the y-intercept is. It's going to be something really small over here. But what I do know is I've got a couple points that I can put onto a table. Specifically, I've got this point here. When x is 2, what is y? So that would be this point here, which has a y value of 75. And when x is 3, that's this point here, which has a y value of 375. And you guys have practiced writing equations from tables a bunch. So you should be able to look at this table and figure out a multiplier for me, and then use the 75 and that multiplier to work backwards and figure out what your starting value is. And then you've got everything you need to know to write the equation. I'll give you guys a couple more minutes, and then we'll go over questions. Questions for right now. And let me get your eyes up here. This one was kind of weird because the point you ended up getting here was -1, 120. Is that the point you guys found? And our a value is 40. So our first equation should have been y equals 40 b to the x. And then if I put these numbers in here, it's 120 equals 40 b to the -1. When we start solving this, we're going to do the same thing. We'll divide by 40 on both sides. And most of you got to here, 3 equals b to the -1. You can get to the answer here by taking a -1 root, but let me show you a better way to do this. If you ever end up with an exponent of -1, what does it mean when we have something with a -1 power on it? Where does something go if it's got a negative power on it? It goes to the other side of the fraction bar. So I'm going to rewrite this as 3 equals 1 over b. That's what b to the -1 is. It's 1 over b. All right, you guys following me? And then I'm going to change this to a fraction because there's this rule in algebra that says if you have fractions on both sides of an equal sign, you are allowed to do the reciprocal of both sides. That means flip the fractions on both sides. So if I flip 3 over 1, it's going to become 1/3. If I flip 1 over b, it's going to become b over 1, which is just b. So that gets me my answer, b equals 1/3. Now, if you used a -1 root from here, that works. When you do a -1 root in your calculator, though, that -1 must be in parentheses. So if you did not get 1/3 or 0.33333, it's probably because you didn't have your -1 in parentheses when you did the -1 root. Hey, look at part D with me, please. I know that we got y equals 18 times some multiplier to the x power. Can I get you guys to look at this line and tell me about the y coordinates of every point on this line? That's always 18, right? The y values never change. Imagine if I made a table out of this line. Every single y value would be 18, wouldn't it? What's my multiplier if something doesn't change? What do you multiply by to keep things from changing? So you should have gotten a multiplier of 1 for this problem because we're not changing at all. We're multiplying by 1. That's why we got that flat line. I gave you my hint in part E. If you use your knowledge for finding a multiplier, you do 375 divided by 75. I probably use my calculator for that, but I think it comes out to be 5. Does that sound right? So once I've got 5 there, then I can work it backwards, dividing by 5 to figure out what my initial value was. So 75 divided by 5 is 15, and divided by 5 again is 3. And once we've got a table like this, my expectation is you guys can write an equation from that in a matter of seconds. Y equals, this would be 3 times 5 to the x power. This one ended up being just like the two problems that we did together. The only difference is that b was negative. So I'm not going to go through all the steps again, but I know our answer was y equals -8 times 2 to the x power. All right, I'm going to pass out your assignments. If you had a chance to do the sequence practice, I'm going to put answers up here so you can check. If you did not have a chance to do this, I highly recommend that you get some practice in with this. There will be a portion of your tests, remember that's 2 weeks from today, that's going to be all about sequences. You still need to be able to look at a sequence, determine if it's arithmetic or geometric, or neither. And if it's arithmetic or geometric, you should be able to write an equation. So check those out. I've got notes up here, but if you need a refresher, I'd be happy to help you out. All right, I'll come around with your assignments. Let's spend our time wisely.